Good morning to you all. Are you able to hear me? Yes, sir. Yes, sir. Okay, so welcome to our lecture today. We are continuing with the trigonometric functions. So last lecture, we saw how we could draw the sine curve or the sine graph using what we know from basic methods or procedures for drawing graphs, just by getting points and then plot them on the XY plane and join them in some curve. So what we remember is that the graph of Y is equal to sine X. So we were able to draw this graph, and we saw that it repeats itself after 2 pi.
Setting the brain. See.
Right, so it repeats itself after 2 pi radians. Right, so this is what we established. So in this case, we actually say that the graph has period 2 pi. So 2 pi is called the period. Okay, so that's what we established.
Recording in progress. Instruction. Vile vya vile ungatwantwatia mavideos yako washtanani
Please, can you mute yourself?
wameshanpa
Right, so this is what we were able to establish the last time. So today we'll start with the other graph, which is the cosine curve. So we want to sketch the cosine curve. Again, we are going to use the same procedure that we used. So we'll start with the table of points. So in this case, our graph is y is equal to the cosine of x. So we come up with some points so that we are able to draw this particular graph. So the first point that we are going to consider is the point 0, and find out what the cosine of 0 is. The next point that we'll consider is pi by 6, which is 30 degrees in this case. And then the next will be pi by 3, and pi by 3 is 60 degrees. And then we have pi by 2. Right, then we'll get the other points as we move on. So let's see, interact. Tell me what the cosine of 0 is. It's a standard ratio. What's the cosine of 0?
One.
One.
Okay, so the cosine of 0 is 1. What about the cosine of pi by 6?
Half.
Not half. The cosine of 30 degrees.
Oh, square root of 3/2.
Yeah, so that's square root of 3/2. And then we move to pi by 3, which is 60 degrees. What do you get?
Half.
Okay, so for pi by 3, we get half. What about pi by 2, which is 90 degrees?
0, sir.
0. Okay, so these are the standard angles. Like I mentioned last time, we are just going to look for standard angles. Now, after pi by 2, give me the standard angle that reflects 60 degrees or pi by 3 in the second quadrant. What is that angle? Yes, what is the next angle?
2π/3.
Sorry?
2π/3.
2π/3. How did you get 2π/3? Right, so that is a question that I think someone asked last time to say, how do you come up with those angles? So let's see how we come up with this. So when you are in the second quadrant, the maximum that you can get in terms of angles size is pi radians. So for you to get the standard angles, what you do is, for instance, we have pi minus pi by 3. So this will give us of course, pi by 3 is in the first quadrant. And so in this case, if you want to find the next standard angle, you have 3 pi minus pi divided by 3. And that's what gives you 2 pi by 3. Right, so that is the next angle. In this case, you have 2 pi by 3. And then what is the cosine ratio of 2 pi by 3? What is cos 2 pi by 3?
-1/2.
Right, so you are in the second quadrant, and the angle that you are considering here in the first quadrant is pi by 3. So it is the ratios of pi by 3, but then since you are in the second quadrant, the sign changes. So in that case, you see that what you get is -1/2 as your ratio. Then the next angle that we are going to get is pi minus pi by 6. Right, so pi minus pi by 6, you can see that this is 6 pi minus pi divided by 6. And that gives you the 6, but with a sign which is negative. So what do we get for the cosine of 5 pi by 6?
One over two.
Sorry?
Negative root 3 over 2.
Right, so it's negative root 3 over 2. All right, so the next thing, of course, here is just the pi. That will be the next standard angle that we are going to work with. And you can see that in that case, what you are going to get is the cosine of 0, but in the negative sense, which is going to give you -1. Right, so this is a trend I wanted you to see. I think I must have mentioned it last time to say the ratios repeat themselves in the reverse order, but the signs change in this particular case because you are in the second quadrant. So now, from the second quadrant, we go to the first quadrant. So for us to be able to get we go to the third quadrant, and we want to just focus on the standard angles in the third quadrant. So now we are beyond pi. So it means that all the angles that we are going to get in the third quadrant will be pi plus something, okay? So in this case, it will be the same standard angles that we have looked at. So we'll start with pi plus pi by 6. So in this case, pi plus pi by 6, you are going to get 6 pi plus pi divided by 6. And that gives you 7 pi by 6. Right, so that is the next standard angle, 7 pi divided by 6. Right, so again, your reference angle is the pi by 6. Just know where you are on the XY plane. So we are in the third quadrant, and we must know the sign of the angles that we get in the third quadrant. So what is the ratio of the cosine of 7 pi by 6? Quickly tell me what the ratio is.
Negative root 3 over 2.
Right, so remember our reference angle is pi by 6, so the ratio is the same, but it is just negative. So you get -3 over 2. Blessings, you want to ask something?
Yes, sir. Why didn't we include 45?
Well, we can include 45, but in this case, I don't need it. You can
All right.
include it, yes. There's no
Okay.
problem.
All right, sir.
Okay, so in this case, that is the angle and the ratio. Next, we have pi plus the next standard angle. Of course, if you want to use 45, you can use it, because it's just the points that we need, which should be able to give us the curve. So in this case, I will use the pi by 3. So we have pi plus pi by 3. And so this gives us 3 pi plus pi divided by 3. So you see that our next angle will be 4 pi by 3. So that's what we are going to use, 4 pi by 3. And now 4 pi by 3, our reference angle, of course, is the pi by 6. So, sorry, pi by 3. And the ratio, we know it, for pi by 3, it is 1/2. But then we are in the third quadrant. The cosine is negative. So in that case, you have 1/2 in the negative. And then you can also look for another angle in this case. So the other angle we are going to get, which is standard in this case, will be pi plus pi by 2. So pi plus pi by 2, you can see that this will be 3 pi divided by 2. So that will be the next angle. So you have 3 pi by 2. And our reference, of course, is the pi by 2 in this case. We can see that we got 0 there. So we are still going to get 0. Okay, so this is how we can go. So we are done with the third quadrant. Then you can move to the fourth quadrant and get the other standard angles. So in the same way, now in the fourth quadrant, what you do is that you are going to subtract standard angles from 2 pi. So in this case, we'll start with let me write it here. So you have 2 pi minus the standard angle that is the bigger, which we are working with here. So we can do, sorry, pi by 3. So we do pi by 3. Right, so 2 pi minus pi by 3, you are going to see that this gives us 6 pi minus pi over 3, which is just 5 pi over 3. So that, yes, 5 pi over 3. So that is the next standard angle that we are going to use. So 5 pi by 3. And our reference, of course, is the pi by 3. But now we are in the fourth quadrant. So we need to know the sign of cosine in the fourth quadrant. And we know that cosine is actually positive in the fourth quadrant. So in this case, the ratio will still be the same ratio we found in the first quadrant. So that, and then the next one will be 2 pi minus pi by 6. And this gives us 12 pi minus pi by 6. And this is 11 pi by 6. Okay, so that gives us 11 pi by 6 as our next standard angle. And the ratio is the same as that of pi by 6 in this case. So it will just be root 3 over 2. And the last one, of course, is 2 pi. In that case, you know that when you add 2 pi, what you are going to get is 1. So you can see how these ratios are in terms of the first quadrant ratios. And so you can easily get them depending on wherever you are on the XY plane. I hope this is clear now for those that were asking how to get the angles. Is there any question? All right, so if there is no question, then we can continue. Now, apparently, I only have 1 minute before this session ends. So I think what I'll do is just to end the session.
Recording stopped.
And then you can join immediately after I end the session. Okay, so this is a table that
Recording in progress.
got when we were doing our table of values. So now let's see how we can be able to draw this particular graph. I hope I can do a better job today. Okay, so let's try to draw this graph. So we are going to use a particular scale, of course, which you should be able to fit with us. So let's see how we are going to use this particular scale. So we have our origin there. Right, so the scale that I'm going to choose is the following. So I have pi by 2. The next is the pi. Then the 3 pi by 2. And then 2 pi. Okay, so starting with our first point, we know that we have x 0, y is equal to 1. So if I have 1 there, and let's say minus 1 here. So our first point is on that place. Next, I have pi by 2. Of course, that point is equal to 0. So the other points you can have half here, for instance, and then pi by 3 is somewhere there, and you have a point somewhere here. Right, so those are the points that we are going to consider. The next one, you have pi. We know that this gives us -1. And then 3 pi by 2, you have that point, which will be 0. And then when you go to 2 pi, what you are going to get is 1. Right, so of course there are other points in between which you can plot so that you can get a smooth curve. Okay, so this is what we get. And so what we need to do now is just for us to be able to join these points that we have in a smooth curve. Right, so I hope I can be able to draw a very nice smooth curve, which looks something like that. Okay, so this is now the graph of y is the cosine of x. So, yes, Mike?
Sir, when coming up with a table of values, is it okay to just use these 4 angles since they are the ones that you are using in drawing?
Well, our interest is a sketch. If you can get a sketch with those few points, that is okay. You know that we just need a few points for us to be able to determine the shape of a particular graph. So yes, you can choose to just use these ones which I've used to connect, because we know the shape anyway. Is there any other question? Right, so we can actually extend this graph like we did earlier for the sine graph. We can actually take it also to the left. So that is the minus 2 pi. Okay, so in a similar manner, of course, the cosine of negative pi by 2 in this case is also going to be equal to 0. So remember that we have the following: the cosine of negative x is equal to the cosine of x. So this is what we established, and also the sine of negative x is equal to the negative of sine x. So using that, we can see that the ratios that we are going to get are going to be similar in this particular situation. So you have 0 at pi, negative pi by 2, negative 1 at negative pi, and then you get another 0 at negative 3 pi by 2, and you get a 1 up there. So this graph can be extended in the negative direction to get that shape. Okay, so this is a graph of y is equal to the cosine of x. And you can see that as you go around the circle, you can go all the way to the infinity in terms of the x direction and minus infinity in the negative x direction. Okay, so we also note that the period of this function is actually 2 pi. So after 2 pi, the graph repeats itself. So you see that when you are here, then you are starting the graph again when you started at 0. So you are starting the graph, so it will repeat itself. When you reach 4 pi, it will come back to 1, and so forth. So that's what we see. Okay. And also I can put a note here very quickly, which probably we have already seen, that if you use the identities that we had involving the sine of an angle plus pi by 2, so you see that this is going to be equal to the cosine of x. So you can use that identity, of course, and then you see that what you are going to get is a cosine of x. So in other words, what we are saying is that when you add pi by 2 to the sine graph, what you are going to get is the cosine graph. Okay, so talking about the period, maybe let me just give you the general definition of what a periodic function is. So a function is periodic so let's call this a function f is periodic if we have that f of x plus p is equal to f of x for any real number p. That is for some real number p. So that's how we would define a periodic function. So the smallest value of p that satisfies this situation is called the period. Right, so in that case, this is what we have. So we have already noticed when we were looking at the two functions, the sine function and the cosine function, that the period which is the smallest value for which this is satisfied for those function is just 2 pi. So 2 pi is the smallest value. So this will be the smallest value for which we have the following. So we have that the sine of x plus 2 pi
Recording in progress.
My pen seems to be tired. Right, so we have now y is equal to the tangent. Let me write this as tan instead of a tangent. Right, so y is the tan x. So again, we are going to use the table of values. So in this case, I will start with the following. So we have the negative of pi by 2. Then we have minus pi by 3, minus pi by 4. Then minus pi by 6, 0. So I'm just picking on the standard angles whose ratios we know, we can easily get. So next we have 0, yes, and then pi by 6, pi by 3, before pi by 3, I need pi by 4. So we have pi by 4, and then right, so let's start with the tangent of 0. What is the tangent of 0? Quickly, what's the tangent of 0?
Zero.
Okay, so the tangent of 0 is 0 because the sine of 0 is 0. Next, the tangent of pi by 6. Yes. Okay, so we'll write it as root 3 over 3. Of course, it is root 3. And then the tangent of 45 degrees is 1, or rather, next we have the tangent of pi by 3. What's the tangent of pi by 3? No one knows. Right, so we have root 3. And then what is the tangent of pi by 2? What is the tangent of 90 degrees? Is this my class? I have a different group today. Yes, someone wanted to say something?
Is it not 0, sir?
It's 0. Okay.
It's
What is the sign
undefined.
of pi by 2?
It's undefined, sir.
Sign of pi by 2 is undefined.
Yes, that's what we
Or the
read.
tangent of pi by 2 is undefined. Which is which?
No, the tangent of 90 degrees is undefined, sir.
Right. So this gives you 1 over 0, which is undefined. Okay. So in this case, we have that range of values. Of course, you can get more values if you have to. But now, going to the left, remember that I gave you those two. Excuse me. The cosine of x over minus x is equal to the cosine of x, and the sine of negative x is the negative of sine x. So in this case, it tells you that the tangent and the sine curve have the same sign in each quadrant. So if sine is positive, then the tangent will also be positive. If sine is negative, then tangent will also be negative. So that is what we are going to use. So in this case, you see that this will give us negative root 3 over 3. To get the negative of root 3. And there we are going, of course, to have undefined. Yes, Timothy?
Yes, sir. I'm just wondering the the value for root, I mean the pi over 6. Isn't it supposed to be 1 over root 3?
For pi over 6?
Yes.
Yes, it is 1 over root 3, which I've written as root 3 over 3. Does that answer your question?
Yes, yes.
Okay. Right, so now we can sketch this particular graph. So to sketch this particular graph, let's now go to our XY plane. Let me try to draw it. Right, so that's what we can use. So our scale again, I'll start with minus pi by 2. Let me write it a bit further. Right, so we have pi by 2 minus pi by 2, and there we will have pi, and then we will have negative pi. Okay, so these are the ratios that we are going to use. So you can see from our ratios that the minimum we are going to get is -1, and the maximum that we are going to get is 1. Right, so that is what we have in terms of x and y. So now, there is something that we have observed. You remember that when a function is not defined at a particular point, we had a name for that particular point, and we called it an asymptote. So in this case, we can see that at the point x is equal to pi by 2 is an asymptote, and also negative pi by 2 is going to be an asymptote. So the curve does not cross these lines. Right, so of course we are also aware from what we have done here. We just get back. So we see that at 0, the value of y is also going to be 0. So in this case, what we have is that the graph is going to pass through that point, which is 0, 0. And then in between negative pi by 2 and 0, if we get back to our table, so between negative pi by 2 and 0, you can see that what you are going to get is the values of x, or rather of y, which are between -1 and 0. So they are below the x-axis. So that gives us a picture of how this graph is going to look like. So we'll be coming to the asymptote. Remember that we will not cross the asymptote. So that is the curve on the left of 0. And on the right of 0, if you can come back, so we can see that the maximum value we have is 1, and the rest of the values are all positive. So in that particular case, you'll be approaching the asymptote, which is the pi by 2, but of course you will not cross it. So in that case, the graph on the other side is going to be something like this. Right, so this is the graph of y is equal to the tangent of x in the range minus pi by 2 to pi by 2. Okay, so we can see that this, of course, this is a trigonometric function. So this graph must be able to repeat itself as you move on. So you also know that the tangent of pi is equal to 0, and also the tangent of minus pi is also equal to 0. So in that case, then, you know that you still have an asymptote here. And of course, the graph, I'll just tell you how it looks like. Below here, it will come like that, not crossing the asymptote, of course. And also here, up here, it will come like that, and it will not cross the asymptote. All right, So this is the graph. Of course, you have an asymptote at 3 pi by 2 on the other side, which you can get. But this is the graph of y is equal to the tangent of x. So what we see is that this graph, it repeats itself. So it repeats itself after pi radians. So that's what we observe. So from negative pi by 2 to negative to pi by 2, you can see that you have a complete graph in that particular case. And if you are to find the length from negative pi by 2 to pi by 2, you see that what you are going to get is pi. Yes, I can see a hand from somebody. Can you go ahead?
Yes, sir. Why is it not that positive pi should go towards positive 1 y huko, then negative pi should go towards negative 1?
What do you mean by negative pi going to negative 1? You mean below the x-axis?
Yes, sir.
Why do you think so?
No, I'm just looking at the integers. Like this is positive pi there. Again, it's dropping towards negative 1 below the x-axis, and negative pi again is going up towards the positive 1 y-axis.
Okay, so if I got you correctly, your expectation of what we have here, you wanted this to look something like this?
Yes, sir.
No, that's not.
Why is it not?
Okay, so for you to be able to tell how this is going to look like, get some standard angles here between pi by 2 and the pi. Okay? So get some standard angles and be able to find their ratio, whether they will be positive or negative. So that's how it will inform you what kind of a graph you are going to get. You can do the same here. You can get an angle in between, which is standard, and check what you are going to get in terms of the ratios. But I've already shown you how the ratios behave in terms of which quadrant you are in. So when you are here, you are in the second quadrant. So in the second quadrant, think of the sign of the cosine and the sine. And then you will be able to tell how it looks like. So in the second quadrant, what is the sign of cosine x, for instance?
Positive. The
Sorry,
cosine
did you say positive?
The cosine in the second quadrant is negative.
Yes. So the cosine is negative and the sine is
Positive.
positive. So in that case, you have positive over negative. What do you get?
So tan will be equal to positive.
My friend. Positive over negative.
Oh, negative, sir. Sorry.
Yes, so it will be negative. So it shows you that the points are below the x-axis in the second quadrant. So that's why this is coming down. I hope that answers your question.
Sure.
All right. Any other question or clarification? Okay. Right, so we said the graph repeats itself every pi radians. So in this case, the period of the tangent of x is the pi radians. Yes, there is a hand from Benefit.
Yes, sir. Can you
Go
please
ahead,
repeat
please.
how you sketched the horses? How you did this the horses, the sketching on the pies, the ones on the positive part side and the other one on the negative sides. Feels like I'm still confused. I'm failing to understand what was going on. So the one which is in between the negative of pi over 2 to pi to the positive of pi over 2, I've understood. Yes, but what I haven't understood is what's this, how you sketch the positive pi and the negative pi.
So you mean the point here at negative pi?
Yes. Yes.
So the question, of course, is what is the tangent of pi or negative pi? So this is the same as the negative of the tangent of pi. What is the tangent of pi? Yes, I'm asking what is the tangent of pi?
If I'm not mistaken, is it not sine of cosine? The negative sine.
Yes, so what is the sine of pi in this case?
The sine of pi side is 0.
So the sine of pi is 0. And what is the cosine of pi?
It's 1.
Right, so this is why we have this equal to 0. So the tangent of pi is equal to 0. And in the same way, the tangent of negative pi is equal to 0 because you just get minus of the 0 or the negative of 0, which is just 0 in that particular case. Does that benefit you? Benefit?
Yes, sir. Thank you very much.
Okay, so please I said that for you to know the shape, just pick any angles in between there, and you should be able to tell whether the graph is below the x-axis or above the x-axis. The only difference here is that we have asymptotes, which happen every pi units. So in that case, you always put in mind that you have asymptotes, and when you have asymptotes, you don't cross, you just go closer to the asymptotes. Okay.
Recording stopped.
So I want to propose that we end here for today, unless there's still another question of less than 1 minute. Right.